And a very warm welcome to this special webinar on the new normal for FMCG powered by IBM Data Science and AI. A few things about us. We are Veracitiz, formed with a vision to provide businesses with high value initiatives across the analytics lifecycle. We are an IBM exclusive business partner, a gold business partner, and we work with leading organizations across industries to help them leverage emerging technologies in order to achieve strong business outcomes. My name is Roscoe. I am a leader for data and AI with Veracitiz. And with me today is Jacky Patel, the director for analytics, who basically heads the data science and AI practice internally. And while we have you here today, let's begin with talking a little bit about how business dynamics have changed over the past couple of months. It's an unprecedented time. It's very similar to probably the Spanish flu or the dot-com bubble burst, or even probably the financial market crash. But businesses are having to deal daily with a number of challenges. Speaking about a few, business priorities are changing very rapidly. First and foremost, workforce well being is being spoken a lot about. It's no longer just the physical well being of an employee, but also the mental well being, with a lot of employees having to face work from home burnout. The remote worker support quality is another aspect that's becoming highly critical to most organizations, especially in service based industries. Gone are the days when you could take arbitrary ad hoc decisions because now the business conditions are so sporadic that they have far reaching consequences. There is a pressure to keep costs down while being able to keep the lights on for the businesses at the same time having to accelerate innovation. Now, decision intelligence takes away the guesswork from all of the decision making. Even leaders are having to adapt to a digital global leadership, not being able to meet employees and subordinates in person. Leaders across the globe are having to take to online methods to effectively steer their business in the right direction. Lastly, there is a focus on end to end value chain optimization. Now, from an FMCG organization standpoint, the first the first aspect of the value chain is the suppliers or the vendors. We need to procure raw materials at the right price at the right time. After which, we need to undertake production planning, replenishment planning, and to effectively carry out the production processes, we need workforce scheduling. After that, we need to manage our inventory. So, inventory optimization comes into the picture. And lastly, for 100% product fulfillment, customer success, we need to ensure that these goods are being dispatched and delivered to the right place in the right quantity at the right time. Now, because there's so many challenges, IBM prescribes a simple method where you can use technology using the analogy of a ladder. The first step you take is make your data simple and accessible. Get it into trusted and governed repositories. Once you have the data, you can take the next step of building an analytics foundation, gathering insight from that data. Next, you infuse machine learning, get cognitive technologies to ultimately help you reach the pinnacle of AI. Let's take this analogy a little further with this analytics flywheel. Every business starts with a plan. You plan, budget, forecast numbers. You next try to figure out what happened, where you report, monitor, and analyze the variance analysis. You try and get a better understanding of what the actuals are versus what was planned or budgeted or forecasted. Any business then wants to know why did a particular thing happen. Maybe a product line is facing a margin dip. Maybe there is a current and a sporadic spike in demand for a particular geography. So you want to identify those trends, those patterns. You want to drill down and look at things at the transactional level. As a business, you also want to further understand how you can develop, deploy, and manage predictive analytical models, which will help you understand what will happen next as a business. And once you know what the future looks like, you want to optimize decisions to ensure that that prediction becomes a reality. And all these steps are nothing but steps in the analytics life cycle. where you start with planning. You then have descriptive analytics that let you know what happened. You have diagnostic analytics that let you know why did something happen. You have predictive analytics that tell you what will happen next. And ultimately, you have prescriptive analytics that lets you know what should we do as a business to make that prediction a reality. Talking from purely a value perspective, let's focus on the x-axis, where the value from modernization initiatives increases dramatically as we move from left to right. Descriptive analytics would be something associated with a business need like understanding market performance, which product is selling at what price, and what are the margins for different geographies. That is, at its best, a simple solution of an MIS, or management information system. But as we move from left to right, we can see that predictive analytics helps me with the business need of understanding what my product demand is going to be, product demand by product category, by probably SKU level, for different geographies, for different depots, for different territories. And the solution here is the predictive analytics solution of demand forecasting. But I am able to maximize the value from the modernization initiative if I am able to adapt prescriptive analytics, which fulfills the business need of managing inventory, where the solution is supply chain optimization. And today, as we talk further about these two solutions, we will also undertake an example in the form of a demonstration. Any traditional finance IT topology looks like the one we have on screen, where transactional systems are the foundation upon which you have a data warehouse where the structured and unstructured information is built into information marts, into data marts, into individual silos or point solutions for different traditional CPM applications or corporate performance management applications. But what goes unnoticed in most organizations is that there is an unorganized, unauthorized shadow decision support layer with heavy activities being conducted in spreadsheets that ultimately filters down the information that is reaching the ultimate decision makers. The functional decision makers, such as operations, sourcing, capex, marketing, sales, finance, get a very filtered down version of numbers that can be that can have multiple challenges associated with them. There could be missing numbers, there could be misrepresented numbers, there could be incomplete numbers altogether, or there may be formulae mistakes. Things that we've all experienced over the course of using spreadsheets for day to day activities. And this is where IBM Data Science and AI gives us the opportunity to have one single integrated platform with all the organized and unorganized aspects connected. And this is this one single platform where members can collaborate across the organization, not only get detailed analytical insight, but also communicate them effectively across the organization. Now that we know IBM data science and AI is helpful, let's see why it's really required with the help of an example. Let's presume you are an FMCG organization that also does the manufacturing. You have one factory. The factory also serves as a warehouse. Now, this factory slash warehouse has just one delivery vehicle. Let's take an example of me having only one customer. In that case, I have only one possible route of delivery, right? Point A to point B. Now, let's make this example a little complicated by increasing the numbers. Let's suppose having one factory slash warehouse, I have one delivery vehicle, but now I have 5 customers to deliver to. Looks fairly simple, right? However, the number of possible routes of delivery to these 5 customers is nothing but 5 factorial. And that's 5 multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1, which is 120. Exponential increase merely by increasing 4 customers. From 1 to 5, there's a jump of one possible route to 120 routes. Let's take this example a little further. Let's say we have 10 customers. The answer I usually get from most people when I take up a similar example is probably 15,000, 14,400 to be precise, right? Absolutely wrong. But then what really is the answer? It's 3.6 million combinations. Because if you guessed it right, it's 10 factorial, right? One factory also serving as a warehouse with one delivery vehicle, having 10 customers to deliver to, has 3.6 million route combinations, right? And that is where we understand the power of advanced analytics. Advanced analytics is the secret sauce of business decision making. Let's try and understand how well kept or how well known is this secret. In a study by The Economist of approximately 500 mid and senior level managers in US and UK, approximately 70% of them said that analytics is very important or extremely important. However, only 2% of them were able to achieve broad positive results. And this is the stark contrast, right? Where businesses or business managers understand that analytics is extremely important. Not a lot of them are able to achieve success with those initiatives. Whereas, on the other hand, let me talk a little bit about IBM data science and AI success stories. Customers that have reposed their faith in IBM technologies have seen huge benefit from a logistics firm such as UPS. They revamped their air network design using IBM data science and AI, and the benefit they are seeing is savings of roughly $40 million a year in costs, plus 10% fewer aircrafts. And if anybody has been to their website recently, you can see that the coronavirus pandemic has not disrupted their operations to a very great extent. We can also take the example of Motorola or Samsung or even Continental Airlines, seeing huge amount of benefit starting from Motorola saving 100 to 150 million dollars a year from effective procurement management to even Samsung having a 50% reduction in cycle times. And when we talk about value, we are seeing multi-million dollar numbers over here. In stark contrast, again, to broadly 2% of people seeing positive results in the US and UK where they are not using IBM technologies. Let's take a few examples and talk about them in detail. We have Carlsberg, India. They were facing a few set of challenges. The challenges were their logistics planning was a labor intensive process. There was a growing business demand, but there was an inability to scale the supply chain planning. They had a huge number of data points, but they were not able to analyze those data points effectively. Therefore, their warehousing and distribution networks were under a lot of stress. The business need, therefore, was to optimize the distribution network to minimize the inventory costs and prepare for business growth. What they saw as a result of implementing IBM data science and AI is a 12% reduction in plant and warehouse inventory. So the inventory carrying cost went down drastically. They were also able to achieve a 50% reduction in depot and distributor inventory. There was a 4% improvement in customer service levels and therefore repeat business as a consequence of that. But as a whole, they improved drastically their distribution and transportation network. Another success story is that of Carrefour, right? A renowned grocery chain operating for close to 40 years now with 15,500 stores and counting. Now, there used to be stockouts due to their inability to manage replenishments. Their staff scheduling process was very labor intensive. There was a lack of insight on customer preferences, on stock levels, on the demand forecast, on the supplier replenishment. Therefore, their business need was to have a single solution to optimize staff scheduling and stock levels. The benefit that they saw by implementing IBM data science and AI is a reduction in unwanted stock levels by 5%. They were able to reduce the store labor cost by 15%. They were able to improve planning efficiency overall by 80%. And when you have a team of 20, 30, 40 people involved in demand planning nearly, an 80% saving is massive scope for effective reallocation of resources internally. Therefore, they had lower stockouts, increased sales, and they were able to standardize the supply chain process across 15,000 plus stores. That's the power of IBM data and AI. Now, going back to the initial analogy of an analytics life cycle, this flywheel, right? We started with planning, descriptive, diagnostic, predictive, and prescriptive. What we've established so far is that data science and AI is the secret sauce of business decision making. And what we are able to provide you today, what we are pleased to show you today, is a real world use case that cuts across three of these aspects. We have demand planning, where the initial demand by product by geography is planned. We have predictive capabilities that tell us statistically what is the probability based on a promotion scheme of a demand showing an uptake or a reduction. And lastly, how do we fulfill that demand by way of logistics optimization? And with that, to prove all that we've said so far, I hand things over to Jackie Patel for a short demonstration on a data science and AI use case that covers multiple aspects. Over to you, Jackie.
Thank you, Roscoe, for the introductions, and thank you very much all for joining this and sharing your time to look at the solution that proves and proven solution for IBM Analytics platform. Let my screen to show the details. So as rightly said by Roscoe, we are going to see the overall solution on demand plan, the promotion effectiveness of each promotion, considering the percentage of schemes and etc., which is provided in the FMCG sector, and the overall optimization of the distribution or replenishment that needs to be done on respective plant or warehouse to a market. So which in front of you is called as workspace, and workspace screen has different modules on it. I'll select the industry use case, and we have different modules there. Demo modules. So here I select the FMCG demand planning, and this is a schematic of the data flow we have built within the platform. So we have historical sales that has been analyzed by the machine learning module, and statistically we get the overall output of the demand from the machine learning model, considering the time series, correlation analysis models. Then we get a final projected value considering the optimum allocation of the stock to a respective promotion, so that once we run the promotion, what kind of projected output that we get, considering the effectiveness of the score for the respective promotions or schemes rather. Then we have a final demand and capacity allocation for the replenishment. So that's something where we wanted to supply our demand with the respective warehouse or a plant. In our case, maybe warehouse, or in a case where you have plants. And then we get the optimal dispatch route allocation. So let's say in warehouse we have 10 different vehicles or 5 different vehicles. Which vehicle should go where, which particular market, depending on the optimum cost and capacity of the respective vehicles. So that's something which we are going to showcase. Please bear with us in terms of this is a kind of a model, and anything else you would like to know, we can have a question answer session at the end of the demo. Okay, thank you. So let's see that how the actual data is analyzed. So we have market wise, product category wise, the information of the past year performance. So the scheme 1, scheme 2, and the full price, how this quantities are being sold, and we can see the view in a detailed manner till from the year to months to weeks to days. So that kind of detail working we have as a data analysis. We have year-wise information as well. So we collected around 5 years of information now, just to analyze which kind of trend which we're following over a period of next period of time. So we have all product category-wise information. So that's something which is market as well. So how the sales are being happened. So we can analyze the view initially. Then the model which we have built on the IBM data science platform. Here we have some flexibility of managing it, the time period. So we can select the time period starting from which particular day and for how many weeks. Let's say if I select for 5 weeks, I want to plan for 5 weeks. That's the 5. And here I just select. Allow me for some disruption in the internet, please. You are able to hear me, right? Or
Yes, Jackie, loud and clear.
actually, I'm not able to connect. Okay. So let's say I want to plan by weeks, and I selected 5 weeks. And then once I update my period, it gets updated automatically. So now it has converted the entire model to a week based prediction. Earlier it used to be a day wise. So let me show you again how that change has happened. This days. And then you have, let's say, update. So you can have a flexibility, like you have the flexibility to run this model in a multiple manner. You can do week wise, you can do month wise, or day wise. So currently we have selected for 1 week, and we wanted to have in a days. So in a backend we have collected some date parameters to get the scheme effectiveness. So now what scheme effectiveness is, that each scheme, how much is the confidence level for the each scheme to have prediction for a particular day. So we have collected these kind of date parameters, where you have holidays, pre-holidays, post-holidays, kind of a information. There you have some of the sales that you are having, like Black Friday sales or stock clearance sales that you have run in the past, the weather uh, and precipitation in impact on particular sale. So maybe that's something also is a crucial in terms of getting the right sales projections. Then you have how much sales have happened for the price or promotion 1, 2, 3. Then it's which month of which day of the month it is. Then you have a quarter of the particular quarter day of a particular quarter, and then the further some of scheme effectiveness of those days based on the quantity sold or based on margin. So you can define multiple ways the percentages just to analyze it or just to map it with a right uh, combination of the driver factors. So these are all our driver factors where the sales of projected sales can be correlated. So kind of data we have supplied along with the past performance for each market and for each products. And then once we analyze information using machine learning techniques, we finally get a projected scheme effectiveness score for a particular day. So depending on those date parameters and next upcoming days or weeks, in our case we have weeks also in place. So the projected demand uses the baseline of a statistical output. So this is something which is projected sales and the projected confidence level for the scheme effectiveness. So we can say that for this particular days in past, we have 3% full price effective. So if we pass on promotion, full price would be 3% effective in terms of driving the sales. And here also could see that the full price projections are very low, whereas the scheme wise projections are high. We can define the scheme related stuff on dynamically. We can modify the model according to the need of the situation, and we get the output for each uh, respective market as well, and product as well. So this way we can have multiple models. So you see, within fraction of seconds, we have past 5 years information, as well as we could achieve some of the scheme effective confidence level and the product demand projected for the next upcoming week or days. So these are all automated manner. We can get it from the IBM analytics platform on a real time, I would say. Then how this scheme effectiveness would be uh, more optimized further with the right product mix on the given scheme. So I run the decision optimization model, which will give me the output in terms of how these schemes can be further optimized in terms of getting the uh, right the sales quantities as well as the projected margin. So I have this percentage used in terms of getting the right mix of uh, products products and scheme allocation. So that's something which will help me to maximize my quantity sales as well as the margin. So here, so numbers are getting they have updated. So I could see that I can still achieve the increase of 6,753 units of sale particular week by just allocating some getting percentage of my stock in a given scheme. So I could achieve additional margin around 1,20,000, and these are all scheme effective rates. So what I can say that scheme number two will reduce the margin by 10%, and scheme number four will reduce margin by 18%. So depending on the optimum allocation, I get the maximum margin. Also, I get the maximum quantity of getting stored. So these are my project uh, quantities, and I should run for a particular stock which I'm having, okay, for a particular product and for a particular market, that what kind of optimum scheme allocation I should have. So this is something where my projection would change over a period of time. So look at a particular market which is Northwest has a particular which has given a different kind of allocation, whereas the other days has different kind of allocation, considering the margin and quantity effectiveness of the given day. So here I can align my I can align my promotions in an optimum manner so that I do not lose my margin as well as I do not lose my quantity of getting sold. So this is one level. Now let's say how the demand will meet the overall supply. So we'll see the how the supply is being uh, done. So this is my total supply requirement and what is my demand considering the overall market need. So let me run a model. We'll see that constraints are working here. So these are market demand and the certain constraints which we have in the model, that what is a planned production capacity or warehouse dispatch capacity. So I have certain limits of my warehouse dispatch as well as my plant of production. Then I have a kind of a transportation cost from a plant location to my respective warehouse locations. So these are all cost metrics. And then certain product information like what is the average volume of those products, average weight of the product, then what is the safety stock that minimum I should carry in my warehouse or the storage locations and in a particular market, and then what is the batch size of the order, and then the lead time and etc. So those kind of uh, constraints which we have planned, which we have in the model, and the planning has to be done using those constraints. These constraints can be customized depending on the overall scenario by product category and market as well. So this is something which will be driving my overall delivery plan, and I could see that there is some delivery plan which has happened and give me a right optimum mix of stock which I should be carrying over a period, as well as the ordering of each respective market and the supply by respective plants. So here I could see that uh, I'm able to save some of the value by reducing the inventories of a given market, and considering that I keep the supply as my demand goes. By market, I could see that. Then let's see the detail of the dispatch plan which tool has suggested me. So this is my dispatch plan over a period that a particular plant to a particular market. Let's say North is my market selected. I can select the Northwest market also, which has a supply from different supply points. So this is an optimum allocation of vehicles as well as the warehouses or plants to a particular market with the lowest cost of dispatch. So this is the cost of dispatch, and this is the lowest cost of dispatch considering the overall demand that market we are having. So this is my dispatch plan. We can have a schedule of the vehicles also further in terms of delivering it to the respective warehouses or the market locations. Let's say we have certain um, customer locations, or we have certain shop locations where we wanted to dispatch our plan. So the vehicles will have kind of a dispatch plan also. We can have a cost based optimization, or we can have kind of a time based optimizations as well, and we can look at the schedule that how the day wise allocations of the vehicles to or route to the customers or shops, or let's say my delivery locations from my respective plants or warehouses is being done. So we have multiple options in terms of defining constraints, arriving at the demand plan, and then supply of those demands, during the overall stock and availability of the material, and then optimum promotion mix that we can have within the platform. Entirely, it will be linked from sales analysis. So you have some sales analysis by day-wise analysis by scheme-wise for a given market. You have scheme effectiveness scoring, or you can define your planning period. So that's you can do by week or by month. Then you have promotion effectiveness working out with the base forecasted values as optimized values. I can change and see that how the optimization of the values is being done dynamically. I can change certain numbers of my scheme rates and again run the optimization so that it will give me the better output in terms of the maximum margin and maximum sales. The demand dispatch plan optimized, the vehicle allocation, and minimum cost of the particular by route. And then I can achieve the schedule also by vehicle, warehouse, and then a supply to a respective market locations as well. So we can use the IBM data science platforms for end-to-end analysis as well as end-to-end demand forecasting and supply replenishment allocations. Here I would end my demo, and maybe Roscoe, over to you for the question answer sessions.
Sure. Thanks, Jackie, for that wonderful explanation. So, it was a wonderful real world example where you not only showed us how one can plan demand manually, how one can get a statistical sense or a statistical forecast of that demand after including or taking into account the effectiveness of the promotional schemes that a business would normally have. Plus, beyond that, also looking for the dispatch plan optimization in terms of cost or time. So you can not only reduce your inventory storage costs, increase your customer satisfaction, but also you can improve the timeliness of order fulfillment. And I think that's a wonderful example, Jackie. Thank you very much. Uh, we'll be looking for questions in the Q&A box. If any, you may please feel free to share. Yeah, we are more than happy to respond to them. So I received a question on personal chat, and the question says, "What is the kind of accuracy traditionally that a business can expect from an implementation such as this?" So, Jackie, would you want to take this one up?
Yes. So, thank you very much for the question. Like whoever has said, so this is very much, it's very much important that we achieve a right accuracy for the forecast. So, what our experience says till date is the machine learning model is a model which learns the patterns and the behavior of the past information. And the machine learning platforms are designed in such a way that it learns the every pattern in a very effective way. Now here we need to provide the past information which are actual drivers of those sales or the effective promotions or scoring that we do for a classification model, for the allocation model we do the decision optimization. So we need a proper drivers from the system so that the learning will be very quick and accurate. So we have achieved more than 80% or 90% accuracies in certain cases where we have better defined the drivers of those sales or actions, I would say. So here we have taken an example where we were able to we actually tried to map it with number of forcing parameters of a particular date, because in FMCG the seasonality, the overall date when the sales are happening, what was there on that particular day, what was the temperatures or the overall weather information on a particular day in the past happened. Then you have certain effective promotions which you have planned for a particular dates in the past. So those are real drivers of the business, why the sales have happened. You can also extend further with the population or the uh, other driving factors like the spending powers or uh, spendings are happening within the area or market. So those things are also drivers to a particular forecast, and we could achieve more than 80%, 85% of the accuracy with those drivers using these kind of platform. And we have achieved also in past more than 90% in some cases. Like I could remember that in a medical in a pharmaceutical company we implemented this demand planning, and we could achieve around 85% to 90% ranging from the product to product the forecast accuracy, and that is very very high from the normal manual industry standard. So manually if you do, you could achieve around 75% accuracy of the projections, and when you achieve 20% extra, it's really helpful for all the optimization possible within the supply chain or within the supplier negotiations, within the distribution negotiations, and etc. So those projections are really helpful as a overall journey for implementing and getting the ROI using the platform.
Perfect. Thanks for that answer, Jackie. Our next question is from Yusuf, where he asks, "What is the average time frame for the implementation of such a solution?" So,
So
would you want to take this up? Yeah.
yes, so Yusuf, so Typically, so every analytics implementation, everyone start with the small. So we have seen that the small POCs or small pilot runs we could achieve within 1 month or 1.5 month as well. So in a short span, we could achieve some of the quick wins, I would say. For the full-fledged end-to-end, so the one which I have seen that I have shown, where you have multiple integrations of the processes, like you have one as a production sorry promotion effectiveness, then you have dispatch optimization, then you have proper allocation of the vehicles. So these are all small use cases which we have tried to show in the demo, and you can define further like production optimization. So you have, let's say, a raw material planning, so you can also uh, define as a branches for the raw material planning. So these are all small use cases which we need to take, and then we need to start the journey for the overall end-to-end implementation. And typically, each use case would take around 1.5 month average, and can go up to 2 months or 2.5 months as well, depending on the complexity, depending on the overall data that we are having, the cleanliness of the data. So let's say your data source is itself is not having some of the information, then you need to collect, and then you need to arrange those information as well. So typically, I would say 1.5 month to 2.5 month would be the right one use case to build. And then end-to-end implementation doesn't have any limit. You can club as many as use cases that you are having within the system. Okay.
Perfect. Thanks, Jackie. And the next question from Yusuf is in continuation with the previous one. What is the average time frame based on our experience when we start seeing some meaningful optimization? And Jackie, I'd like to initiate the answer or the response on this one, and maybe you can add insight based on your experience.
Sure.
So, what I've seen typically is apart from IBM solutions being highly simple to use in an environment where there is no lack of complicated technologies. So IBM is really working to simplify and demystify the complicated technologies such as AI, ML, cognitive, and so on. And also the partner ecosystem that is aligned with the delivery of these solutions is highly flexible. To give you an example, we recently were in conversation with the customer wanting to go ahead with not only a data lake implementation, but also a data warehousing implementation. And aligned with that were certain advanced analytics objectives such as enterprise BI, predictive analytics, as well as decision optimization. And the flexibility from an IBM implementation standpoint is such that we were able to suggest to the end customer organization a parallel delivery of both these tracks, where we split one track as data lake and data warehousing, and track two had enterprise BI as well as predictive analytics and decision optimization. So right off the bat, we were able to cut down the delivery time into half by way of approaching the implementation with these parallel tracks. And the meaningful optimization really has a lot to do with what is the organizational objective. If I have to take the example of the demonstration Jackie took us through, we could optimize either for cost, where we would have to compromise on the timeliness of the delivery by way of lower cost, or we want to optimize for the timeliness of the delivery, and therefore we have to sacrifice a little bit on the cost aspect. And depending on how quickly, also there are multiple other success factors, one of which is also how quick is the organization to adapt the insight that the data science and AI solution has to offer. So, bottom line being, it's a host of multiple factors, multiple success factors. You have the solution design, you have the executive buy-in. It's also important to ensure that there is organizational or end user buy-in, so that departmental or functional heads are seeing to it that the insight is ultimately executed as well. And lastly, what is the organizational benchmark? Again, if I have to relate to the example Jackie gave, the organization we worked with had a benchmark of 75% manually, but that was only for 200 products and for two warehouses. to central warehouses. And what we were able to do by way of an optimization model is extend that forecasting in a statistical manner for 1,000 products, so 5 times increase in the number of products. We did it for 35 depots plus the warehouses, so an exponential increase in the number of geographies covered. And plus, the accuracy went up, most importantly, from roughly 73% to 85%. And therefore, the value was all pervasive. Like Jackie mentioned, it came handy in distributor negotiations, in supplier negotiations. Production planning was more efficient because the demand was now statistically close to 100% accurate. And therefore, the meaningful optimization really depends on what an organization is looking for and a few other success factors. I hope that answers your question, Yusuf. And Jackie, you may please feel free to extend some insight from your experience as well.
No, Roscoe, it is perfect.
All right. I have another question over here that says, how much does it cost to invest in a solution like this? So, Jackie, if you're fine, I would like to take this up.
Answer this, no
Sure.
problem.
So, typically, while an implementation has two cost components, one would be the services component, which the implementation partner charges, as well as the software component. Again, it really depends on the flexibility of the organization. You might either want to have a low a capital investment and go ahead with a cloud-based version of the services, so you can start quick, you can start small. The overall total cost of ownership might be a little lower. However, in the long run, since it's going to be a recurring investment, it might be a little expensive. On the other hand, if you go for on-premises kind of an investment from a software perspective, you need to procure the necessary hardware. You need to set up the infrastructure. You need to have the right IT team internally to support that infrastructure. You also have a heavy capital investment upfront. So it does not exactly provide you the flexibility and scalability, because that is something that gets sacrificed when you go ahead with an on-premises kind of an investment. From a services perspective, I would say ultimately it's a very modular approach. You may have X component for data lake, you may have Y component for data warehousing, you may have component Z for enterprise BI, component ABC for predictive analytics, decision optimization, and the other. So it really depends on what you're looking to do. And my advice to every organization that we work with is look at the return on investment, look at the value that you are able to generate rather than the upfront cost. Because we've usually seen that these analytics initiatives recover or face a break even in probably 6 to 12 months. And thereafter, the solution is literally paying for itself. To give you a simple example, one of the optimizations that we conducted is where a team of 10 members used to manually conduct the processing of incentive compensation on a monthly basis. That was reduced to merely 3 people. So there were 7 resources, which if you take a standard a pay of $60,000 a year, that's roughly $5,000 a month. And the organization was able to save roughly $35,000 a month due to lack of additional labor required for processing. So a labor intensive process was now system processed, it was system driven, it was highly accurate. There were lower complaints from the agents. From a payout perspective, the payout process became highly transparent because it was systemized. The agents could get automated reports as well. And the cost saving itself was so wonderful that the organization was able to recover their investment in the first 12 months itself. Thereafter, the solution really pays for itself. And since again, IBM solutions are blank slates, blank templates to carry out whatever business case you so desire, it's not only one use case that you can build on a particular platform, whereas you start with a small departmental use case, such as the organization I'm quoting that started with an incentive compensation management program on this particular platform. They extended it later on, looking at the benefits of remote collaboration and fast processing time, quick consolidation. They also incorporated an annual budgeting exercise on this very platform without having to invest additionally in the procurement of software. because the software already existed. So overall, IBM solutions really have a low total cost of ownership, and the initiatives pay back for themselves within the first 6 to 12 months itself, provided we've identified the right business use case. So I hope that answers that question.
So, Roscoe, we have another question from Yusuf.
Sure.
Yeah. So, Yusuf, I understand that you must have seen the slide which says the analytics field. Roscoe, can you just go to that slide again? So that slide is a very clear picture saying that you can start from anywhere and you can roll it from starting from the planning, starting from the what happened to understand what all diagnostic analytics that you want to build in your organization, and you have a kind of a predictive model or a forecast demand forecasting model, and then the prescriptive, which is actually the scheduling, the one which we have seen, or the kind of the allocation of the resources. Okay, so any of the use case can be selected for a distribution industry. Okay, but I would prefer that in a distribution industry you certainly have the inventory planning, and considering inventory planning you have to have a proper dispatch schedule to be designed. So I think if you start from there it would be much beneficial, what my our experience says in terms of getting the ROI quickly from the investment. Okay, so if you start from those the last level of the process, or let's say first level of the process, like we have seen, the demand planning is also crucial to align the uh, align the resources. Okay, and then the resources like vehicles or the teams, distribution staff also, if you have, then that is also one of the use case to align them in a right optimum manner. So depending on the your priorities, we would suggest that you can take any of the example and you can expand it to any of the level. So we have worked in both of the kind of a solutions. One of the we can say stationary equipment manufacturing company. We have worked with them. There they have started with demand planning and extended till the distribution of the warehouses. And same like pharmaceutical, the one which we discussed. There also we have done the demand planning, and then from there we have the overall requisition planning as a next step. So we have all the use cases to start with or to end with, the entire process from the beginning to the end, and mapping them for the overall benefit for the organization.
Yeah, and to add to that, Yusuf, my point would be that first of all, the most fundamental question that needs to be answered internally by the company and by the enterprise itself, if there is a need to have an analytics initiative undertaken, right? We need to understand what is the size of the organization, what is the complexity of the processes that exist internally, and ultimately, is there any scope for improvement? If I have to take the very same analogy of one plant slash warehouse that has one delivery vehicle, delivering to one customer is not a problem. You would probably not need analytics for that. Once that business increases exponentially 5 times, now you have 5 customers, you have 120 possible decision optimization routes, possible routes of delivery. That is where things start to get a little bit tricky, and you probably want to have analytics on your side. Whereas in the last case, where you have 3.6 million possible delivery routes, when you have just 10 customers, so a tenfold increase in the original business size, that is where you definitely would not be able to manage things with a labor intensive process, right? No matter how many amount of hands you have on deck, it's not going to be humanly possible to do the number crunching to see which of the possible 3.6 million route options is the best. And that is where certain businesses start with one customer on day one itself, where they foresee a rapid expansion of the business. So they want to be prepared to handle that increased volume or increased complexity. taking the example of Carlsberg that we spoke earlier today, they were unable to conduct effective staff scheduling, or that was the case in Carrefour, pardon me. But in the case of Carlsberg, they had a growing business. They were unable to serve the anticipated demand. There used to be instances of stockouts. So you don't want to be implementing analytics once things have already started becoming too problematic or too complicated to handle. You want to start ideally a little bit earlier, provided the organization can manage the investment. And not just that, you also have the people internally as part of the project team that will drive that project to fruition, that will make it successful. So the fundamental question, my perspective, that needs to be asked internally within the organization is, how bad is the need? How urgently do you need an analytical solution that will ease your trouble? If at now the business is doing fine, if the complexity is not too much, there's not too many variables involved, not too many constraints, if it is being handled manually with a high level of accuracy, I don't think that warrants a need or justifies the business case for an investment. However, if you foresee that the business is going to grow drastically, there's going to be an exponential increase in the complexity, the number of variables, the number of constraints involved, then probably you can have a very justified business case for an analytics or AI investment. And I hope that helps answer your question. Perfect. Any other questions from anybody else? I don't think we see any other questions. Perfect. Uh, with that, I think we can bring our Q&A session to a close. On behalf of the entire Veracitiz team, I would like to thank all of you for participating in this webinar with us. And do follow us closely on YouTube. We are going to be posting this link there as well. You can share it with people who you think would benefit from the discussion we've had. Thank you very much for helping make it a very meaningful conversation by way of the questions that were asked. We hope we were able to answer all of them. Please feel free to reach out to us separately by way of mail as well. And thank you very much. I look forward to seeing you next time.
Thank you very much, all. This is Jackie.